2.5, which is regarding proving statements, where we're going to do more of our proofs. All right, so here we go. The wonderful world of proof, which I think these things get a bad rap. So let's draw three angles here. Two acute, 1 and 2, and then a third angle, which is not, which is going to be obtuse. So what we're given in this situation is that angle 1 is supplementary to angle 3, all right. Moreover, that angle 2 is supplementary to angle 3. And this is going to be actually a proof that we're going to use for a later theorem. And what we're going to prove is that angle 1 has the relationship of being congruent to angle 2. So we need a little congruent sign in between the two of them. All right, so here is our proof, because we don't know this to be true, or generally speaking, that when we have two angles that are going to be supplementary to the same angle, that they in fact are going to be congruent, okay? We can prove that, and then we can actually utilize that reasoning forever, right? What we're going to have then is a theorem, and theorems are handy because rather than living through a long-winded explanation, we've proven a relationship to be true. We don't have to go through and do that. Just imagine the scenario where you have a car that you start. Now, we could explain all the inner workings of the combustion engine, including from the moment that you insert a key into an ignition cylinder and turn it over. But instead, we actually just hand somebody the keys and say, start the car, okay? So in a similar fashion, what we're going to do is kind of prove that this relationship exists, and then we don't have to relive this every single time. So what we're going to start with is, of course, restating that angle 1 is supplementary to angle 3, and of course angle 2 is supplementary. You guys see me abbreviating heavily here, because why write the whole thing, right? And that's just showing what was given to us to prove this problem. So angle 1 supplementary to 3, 2 supplementary to 3. What that means is that angle 1 and angle 3 have a sum of 180 degrees, as well as angles 2 plus angle 3. Now, gentlemen, this is not angle addition, right? Because angle addition would be angle plus angle equals a whole angle, like a combined angle. That's not what this is. All this is that if 1 and 3 are supplementary, then it means that 1 plus 3 is 180, and that's just their definition of supplementary angles, right? So again, on the right-hand side, we're going to say definitions, properties, postulates, and theorems are going to go in there. And we have that definition of supplementaries going in. Okay, so 1 is congruent. 1 plus 3 is 180. 2 plus 3 is 180. And we're going to say that angle 1 plus angle 3, since it's equal to 180, is equal to angle 2 plus angle 3, since it's equal to 180. And again, that's employing the transitive property. A equals B equals C, then A equals C. Next. Both have angle 3 added onto them, so can't we just say angle 1 is equal to angle 2, right? We just subtracted off angle 3. So just subtraction, right? Thinking about our last lesson. Therefore, our last step here, what we need this to do is look like this. So right now we have the measure of angle 1 and the measure of angle 2, and what we're saying is that angle 1 is congruent to angle 2, and that's through the definition of congruence. Okay, so I want to get something out of the way. I'm going to be okay with us not taking steps 4 and 5 and actually skipping right to step 5. The definition of congruence states this. It's a matter of notation. Okay, definition of congruence says that if we have the measure of two angles that are the same, angle 1 and angle 2, then those angles are in fact congruent. Okay, I don't need you guys to state that. I actually know you know that, so there's no need for an additional step when you're actually solving these problems. So the definition of congruence in any proof done for me is not going to be necessary for you to write down. It's a way that a little bit of departure that I take from other, math teachers. All right, so we're gonna name that property. There we go, let's play a little game. If that's the case, first of all, we have angle A is congruent to angle A. What property is that? Well, when something's equal unto itself or congruent unto itself, gentlemen, that is the reflexive property. Now, your textbook goes through and makes a note that this is the reflexive property of congruence. I don't need you guys to denote that difference between what's going to be congruent and what's equal. So, how about if we had PQ congruent to JG and JG congruent to XY, then we could say that PQ is congruent to XY. Property? Well, of course, that's the transitive property, which we're very familiar with. All right, last proof for today. Let's make this guy a little better. Here we go. We're going to have on our diagram, we have L, we have M, we have N, and we have P. What we have given here is that we have this ray MP, which is going to bisect this angle that we had, angle LMN. And what we're going to prove together is that 2 times the measure of angle LMP is going to be equal to the measure of angle LMN. And I'm not going to need you guys to make all those distinctions of the definition of congruence and whatnot, so we're just going to jump right into this proof, right? We're going to have our 2 columns. The left column is statements, right column is reasons. And of course, MP, the bisector of angle LMN, is given to us. Now, what that means. That means is that I have 2 congruent angles here. If MP bisects it, it means that angle LMP is going to be congruent to angle PMN. And that's just the definition of the bisector. All right. Well, that's excellent. So, moreover, in order to get the entire angle LMN, the way it's created is that we're going to actually take the sum of these 2 angles, LMP and PMN. That's how we get this larger angle, LMN. Gentlemen, that is angle addition, right? It's not just regular addition. It's the angle addition postulate, where you have one angle plus another that's going to create a larger angle. Angle plus angle equals angle. Okay, almost done here. Now, if we know LMP and PMN are the same, watch. Couldn't I just say that LMP plus, remember, LMP and PMN are the same, so I could just say plus LMP is equal to angle LMN. And all we did was just substituted. Now think about this, sidebar. Remember, x plus x is equal to 2x, right? So what we could say here is that LMP plus LMP is equal to 2 LMP. And that's equal to the measure of angle LMN. And all we did here was addition. Now, there is another justification you could use here, right? Because we effectively factored out that 2. You could also say distributive, and I would accept that as an answer. So again, it just depends on how you look at it, and both justifications will work here. So they're both going to be accepted. Both answers are going to be okay. Okay, go ahead and log into Canvas and complete your assignment. Good luck.